So we were discussing about the tangents and the normals, right? So tangents and normals of parabola. So here actually we proved that for a straight line to be a tangent to the parabola, the condition is C is equal to A by M. So this is the condition for y is equal to mx plus c to be a tangent to the parabola for y square is equal to 4ax, right? So here actually, sometimes actually it will be asked in a different manner. That is, suppose, so the equation is actually y is equal to mx plus c. Now, we know that actually S1 is, or S equal to 0 is defined as, so y square minus 4ax. So this is S. And S1 is nothing but y1 minus 2a into x plus x1. So this is S1. And then, so S11 is nothing but y1 square minus 4ax1. So this is S11. Now S2 can be treated as y2 into y minus 2a into x plus x2. Similarly, S12 can be treated as y1 y2 minus 2a into x1 plus x2. So these are the standard conventions that we have discussed yesterday in the case of any conic sections what we are going to use. Now in this actually, let us say there is one point at this particular location. This point is located as x1 y1. So let us say the point is of P. And similarly, there is one more point here. The point is of Q. And let us say this is x2 comma y2. Now these two are the points. Now the line joining these two random points, whatever I have selected, and the equation of this actually S1 plus S2 is equal to S12. So this is the equation of the chord joining the 2 points. Points P and Q. So this is the equation. Now here actually we need to understand how it is going to be. So this is the standard convention what we are going to use. Now let us say there is one point which is located at x1 y1, and for that actually the S1 value. So here actually this is the condition what we are thinking of. Now this is S1. So S1 and S2 if you add it together, so S1 is equal to y1 minus 2a into x plus x1. So this is actually S1. Similarly, S2 is equal to y2 minus 2a x plus x2. Now S1 plus S2 if you calculate is equal to, if you add these two together, y into y1 plus y2 minus 2a into, so this is 2x plus x1 plus x2. So this value, now here actually this is equal to S12. So S12 if you substitute it here, so this is y1 y2 minus 2a into x1 plus x2, right? So this is the equation. Now this equation if you simplify it, here this is y1 plus y2 minus 4ax minus 2a into x1 plus x2 is equal to y1 y2 minus 2a into x1 plus x2. Now this value and this value will cancel out. So we left with y1 plus y1 y2. Okay. So here actually this y2, sorry. Yeah. So this is y1 plus y2 minus 4ax minus y1 y2. This value is equal to 0. Or this can be treated as 4ax plus y1 y2 minus y into y1 plus y2. And this value is equal to 0. Let me cross check this. Yeah, this is correct, right? So this is the equation given by the S1 plus S2 is equal to S12, right? So this is the equation. Now actually to prove that whether this equation represents the chord or not, for that what we can do is we can substitute both the points which are on the chord. So that is the previous point is, so this is one point where x1 y1. So this equation actually we just proved that this is going to be of Fourier times of x1 plus x2, Fourier times of x plus y1 y2 minus y into y1 plus y2. So this value is equal to 0. This is the equation by getting s1 plus s2 is equal to s12. Now here actually this, if you notice, this is the equation of a straight line because this is x power 1 and y power 1. So rest of the values are only the constant values. Now if you substitute x1 y1 in this equation, so 4a x1. So the equation is 4ax plus y1 y2 minus y into y1 plus y2 equal to 0. This is the equation. For that actually x1 y1 if you substitute it, now 4a x1 plus y1 y2 minus y1 into y1 plus y2 equal to 0. Now this is 4a x1 plus y1 y2 minus y1 square minus y1 y2 equal to 0. So this y1 y2, this y1 y2 will cancel out, and this can be expressed as 4a x1 minus y1 square is equal to 0. Or this can also be written as equal to 0, y1 square minus 4a x1, even this also is equal to 0. This essentially s11 equal to 0. Got it? So s11. So this actual finally is coming out to be s11. We know that s11 is equal to 0. Why? Because s11 is a point on the curve itself. So if it is a point on the curve, then actually obviously s11 is going to be satisfied. So if this is the point x1 y1, now actually for the curve s is equal to 0, s11 will be equal to 0 because this point lies on this particular curve. And if you notice, this curve actually on this particular straight line, we substituted this point, and this point actually shows that it even satisfies the equation of s11 equal to 0, which essentially means that this point lies both on the straight line and on this particular curve. So this is how actually you can put it. Now there is one more point here. So here actually we know for sure that s2t equal to 0. Why? Because s22 is nothing but it's a point on this particular curve itself. Hence actually the curve s22 will be equal to 0 as this particular point is x2 comma y2. Now if you put these values in the original equation of this straight line, so here actually 4a x2, this is case 2. So 4a x2 plus y1 y2 minus y2 into y1 plus y2 equal to 0. So this equation, if you notice, 4a x2 plus y1 y2 minus y1 y2 minus y2 square, this is equal to 0. So this is cancelled out, and then actually 4a x2 minus y2 square equal to 0, or this is y2 square minus 4a x2 equal to 0, which essentially means that this is s22 and it is coming out to be 0. So here actually this is nothing but the point on this particular curve. So at the other point, that is x2 y2. Hence actually both the points, that is x1 y1 and x2 y2, lies on this particular straight line because this is satisfied, and you know that actually s2t equal to 0 because the point is on this particular curve itself. So these are the nothing but the intersection points of the curve and this particular straight line. So this is nothing but the chord joining x1 y1 and x2 y2. So this is the chord joining x1, y1 and x2, y2. That is the equation given by this, right? Got it?